All right, ladies and gentlemen, today we are jumping back into math with lesson 6.6, converting units of weight. So today, unlike last week, we are back into the curriculum, meaning we're learning new stuff. Now, luckily, this probably feels familiar as we look at today's because we've done a lot of converting this year and you guys are rock stars at it. So we're going to keep that up. Today, along with the video, you're going to need your math notes for lesson 6.6 as well as your workbook. Okay, now I want to point something out. It asks you to do lessons, math workbook page 204 to 205. Okay, now when you look at the independent practice slides, 5, 6, 7, 8 are the exact same questions that you're going to see on page 205. What I want you to do is solve them in your workbook, however you need to, and then I want you to put your answers on the slides for me. Okie dokie, that way I can check our understanding that way. All right, our Ed Connect game today is addition topic. Again, guys, remember this is linked for us, so we can just go ahead and click into Ed Connect. And then for our fluency practice, we are going to do IXL N5. So once again, if you click into IXL, you are going to log in, and the first thing you're going to see is that recommendation slide, and that's where you'll find my recommendation for N5. Okie dokie, my friends. Take a moment. If you don't right now, pause the video, go and get your math notes, a pencil, and your workbook so that we can get ready to rock and roll. All right. Okay, let's look at our notes for 6.6, customary units of measure, starting with our math message. Let's think about this real quick. Would a stapler weigh about 7 ounces or 7 pounds? Think about that for a minute and decide which one you think makes more sense, 7 ounces or 7 pounds. Okay, I think 7 ounces is going to make more sense here because 7 pounds is like the size of a newborn baby. And it seems kind of crazy that a stapler and a newborn baby could weigh the same. So I think it would make more sense for our stapler to weigh about 7 ounces. Now, don't let this one trick you. Might a car weigh about 1 ton or 2,000 pounds? What makes sense there? If you said both, you're correct. They both make sense because 1 ton is equal to 2,000 pounds. So it would make sense that a car would weigh about 1 ton or 2,000 pounds. You could look at it the same way. So we have one vocabulary word that we're going to work with today, ladies and gentlemen, and that is the U.S. customary system. Now, we've already talked about the metric system. And when we think about the metric system and we're thinking about weight, we're thinking about things like gram and kilogram. So just a quick reminder, bringing back that prior knowledge. When we are talking about the customary system, we're looking at 3 different measures here. We're thinking about tons, pounds, and ounces. Okay, so 1 ton is equal to 2,000 pounds. Think of it like a car or a giraffe. I had to stick with our animal thing after our San Diego Zoo last week. 1 pound is about 16 ounces. So if you've gone to the grocery store and you buy a pack of butter, that's about 16 ounces. Or most like adult shoes weigh about 16 ounces. Okay. And then the smallest weight that we're going to talk about in US customary measures is an ounce. And that's like the slice of bread or like a DVD disc. That's about what that weighs there. So our 1 ton is 2,000 pounds. 1 pound is 16 ounces. And those are our conversion rates. Not quite as pretty and easy as our metric system, but we know what to do with them. We can make it happen. So let's do some quick practice together before we go into our workbook. Ooh, going for a ride. So first practice question. How can you convert from tons to pounds? So if I wanted to go from tons to pounds, what am I going to do? If you said multiply by 2,000, you are correct. So because we know that 1 ton equals 2,000 pounds, we can multiply however many tons we have times 2,000 to get the amount of pounds something weighs. Okay. How do we convert them from pounds to ounces? Think about that for a moment. How would we convert from pounds to ounces? Good job. Okay, if you recognize that once again, we have to take our pounds and multiply times 16 because we know that 1 pound equals 16 ounces to figure out the total number of ounces something is going to weigh. You rocked that one. All right, let's look at this last question here. What happens when we convert a larger measure of weight, for example, tons, to a smaller measure of weight? So what happens when we go from larger to smaller weights? What do you notice about this? Well, if you're thinking, well, I noticed, Miss Denton, that we're multiplying when we go from a larger measure of weight to a smaller measure of weight. What normally happens when we multiply? Things get bigger. You're right. So our answer gets larger. The number in and of itself gets larger. So if I have 2 tons, that's a lot of weight. But if I want to figure that out in pounds, I have to multiply that by 2,000. So 2 tons equals 4,000 pounds. So when I went from a larger measure of weight to a smaller measure of weight, my answer got larger. My number physically got larger. Okay? All right, so let's practice this as we go into our workbook. So I want you to open up your workbooks to page 204. So grab that workbook and open up to page 204. All right, friends, looking at page 204 for lesson 6.6. I want you guys to notice something at the top of the page. It has a little handy dandy helper for you. They are some comparison scales, okay? So we have from our conversion of pounds to ounces, we know that 1 pound equals 16 ounces, and then it continues for us, so we have to do less multiplication. And then we see one down here from tons to pounds, and we see that another scale. If we have 5 tons, we have 10,000 pounds, okay? So we are going to use the measurement scales to help solve the problem. So let's start with tons together. Let's do number 1, okay? If we know that 1 ton is 2,000 pounds, well, how much is 2 tons? So we can come up here to our scale and say if 1 pound or 1 ton is 2,000 pounds, 2 pounds must be 4,000 pounds. So I'm going to fill that in on my chart. Okay, what's 3 tons then? Using my scale, I can see 3 tons is 6,000 pounds. Awesome job. All right, last one. How much would 5 tons be? 10,000 pounds. Okay, that one was super easy. Let's take a minute. Now notice number 2 has us going from pounds to ounces, so we're going to use the top measurement scale. Take a minute, use this scale to fill in number 2, okay? So let's see, 1 pound, 16 ounces. So how much is 3 pounds? 48 ounces, good job. Okay, what about 4 pounds? 64 ounces. And 7 pounds. How many ounces are in 7 pounds? 112. Good job. Okay, now these bottom 2 require a little bit more multiplication practice, but I think especially you guys would be great at it, so let's not stress. So now we have to think about if 1 ton equals 2,000 pounds, I am going to just write that little cheat up there for me so I have it handy dandy. I can think about what do I need to multiply. Now recognize, guys, I can think about these like extended multiplication facts. So I can multiply all of these tons by 2 and then add in my 3 zeros after. So I can say, well, 9 tons times 2 is, 9 times 2 is 18, 1, 2, 3 zeros. Okay, so easy peasy that way. Let's look really quick at 20,000 pounds. Now we need to reverse. So before we said that when we go from a larger measure to a smaller measure, our answer gets bigger. What happens if I go from a smaller measure to a larger measure? It's going to get smaller. Good job. So I have to think about, what is 20,000 divided by 2? Or by 2,000, I'm sorry, guys. So let's think about it like an extended multiplication fact. Let's think about, what is 20 divided by 2? Well, 10. And I can think about 20 divided by 2,000, 3 and 3, so I don't have to add any more zeros because they're all accounted for. Okay? What about 14? So 14 times 2 is, that math, 28. How many zeros do I need to add here? 1, 2, 3. 1, 2, 3. Okay, here's an easy one. What's 25 times 2? 50. How many zeros am I adding? 3. Y'all got that down. Okay. Let's look up here, or let's look at number 4. We can use our scale for at least the first one. So 8 pounds is how many ounces? 128. So thinking again, I'm going from a smaller measure to a larger measure. What's going to happen to my answer? It's going to get smaller. So find 144 ounces on your scale and figure out how many pounds that would be. 9. Okay. Now, I have to do some multiplication here because my scale only goes up to 10. So I have 12 pounds. I need to figure out how many ounces are going to be in 12 pounds. Now, what I would do here, ladies and gentlemen, is I would break this up to 10 plus 2. So how many ounces are in 10 pounds? 160. Good job. How many ounces are in 2 pounds? 32. So I made that into friendlier numbers, and now I can add these together to figure out that 12 pounds is going to be 192 ounces. Okay. Now with 20, 20 is a pretty friendly number. You can break that into 2 tens, right? Or I can say 20 times 16 is really just 2 times 16. And I can add, do my math down here, 20 times 16, or 2 times 16, 2 times 6 equals 12. Carry the 1. 2 times 1 is 2, 3, 32. And I have a 0. So I'm going to have 320 ounces, friends. Okay? All right. Let's do one of the word problems together. Let's look at number 5 together. Now you have your sliding scales on the other side. So it says, whoa, these are going to be tough words. Don't make fun of me when I pronounce these wrong, okay, guys? A Compsognathus dinosaur weighed approximately 8 pounds. So that's going to be important information. I'm going to mark it. An Archaeopteryx weighed approximately 2 pounds. About how many more, ooh, this is important, ounces, I'm going to have to do some conversions, did that dinosaur weigh than an Archaeopteryx? Okay, so here's my question about how many more ounces did the bigger dinosaur weigh than the smaller dinosaur? So about how many more? That tells me I need to do some subtraction. So I'm going to start with what's easier first. I'm going to say 8 pounds take away 2 pounds is 6 pounds. And then I can look at my scale on the other side to figure